Welcome to Hope Academy. My name is Mr. O, and today I'm going to be going over the SAT 2 Math Level 2 subject test, specifically the practice exam provided by CrackSAT.net. So I'm going to be going over numbers 4 through 6, and so what I usually do is I do the question real quickly and then explain it in depth how to do the problem. So I'm going to go ahead and get started. So for number 4. Okay. Basics right here. For number 4, my final answer is A, and now I'm going to explain to you how I was able to get to the answer. So for this question specifically, the important skill you need to understand is this concept called SOHCAHTOA. And it's an acronym that helps us understand how to do this. So there's two strategies I use. I use SOHCAHTOA and I also use a strategy called special triangles. So I do want to point them out before I continue. So when we're doing SOHCAHTOA, for example, the idea behind SOHCAHTOA is the fact that each of these letters represent a certain, like term. So it's sort of like the acronym in a sense. So S will represent sine, X will equal to opposite, and I'm following this, opposite over hypotenuse. And I'm going to go through all of these just in case you need to review on this. For cosine, it's going to equal to adjacent over hypotenuse. And for tangent, for t right here, it's going to be opposite over adjacent. And so for this question right here, what happened was I knew right off BAC. When it said BAC, I automatically knew that I was going to use this angle and then help me solve out for the rest. And so I knew I needed these two sides. And so using these points right here, the distance between 13.4 and 13.9 is the difference between the y coordinates. And so right here, I noticed right off it will be 5. And the reason why I looked for this value is just because there is a special triangle rule that does exist, and it's the rule is the 5, 12, 13 triangle. So that's one type of special triangle that does exist, 5, 12, 13. Another common one that comes out is 3, 4, 5, and 7, 24, 25. But for this question, I'm looking at 5, 12, 13. And so right off, I just checked to see whether or not that special triangle rule will be fulfilled. So right here will be the distance for the x coordinates. So between 1 and 13 will be 12. And so right off, I know it's 5, 12, 13. And thus, this is going to be my opposite. This was going to be my hypotenuse. And thus why I knew it would be 5 over 13. Thus why my final answer is A. And that concludes my explanation for number 4. So I'm going to continue on to number 5 and continue on, working through this. So number 5. Which of the following is a complete solution for the set? Okay. Interesting. Okay. Okay, I gotta do this. Okay. Nice 25. Okay. Okay. Interesting. So what would be the possible values for x? -4 and 3. So for number 5, my final answer is D. And now I'm going to go ahead and explain to you a bit how I was able to do this question. So for number 5, I do actually need to do this on a separate piece of paper just to help you explain this in a more clear sense. And so I'm going to go ahead and copy down exactly what is stated. So A equals to these brackets x, y. And they're not as important. The important thing is this equation right here, the x squared plus y squared equals 25. I didn't really disregard anything else afterwards just because I started realizing after a point when I was working through this that it wasn't going to really help me. And so because these two equations are right here, I pulled them out right off in the beginning as it showed when I was solving this out. Afterwards, I realized that in order to solve this question, to find all possible solutions for this question, there's a concept called substitution that I need. So I'm going to write right here, substitution. Okay, and so substitution would help me solve for one specific variable for this question. And so for this question, I knew right off it will be me substituting out y right here and replacing it with x plus 1. Thus what I did right here. Okay, and so I did x squared plus x plus 1 squared equals to 25. Afterwards, I needed to FOIL this out, and thus you could do box method right here. So this part right here, you're going to need either box method and such, so box method, or you could use, you know, diamond method. You could use just a standard factoring sort of format. But that being stated, right off, when you do that, it will be x squared plus, this whole thing will become x squared plus 2x plus 1 equals to 25. And I was able to mental math that. So after you get a lot of practice, it will save you time to just know how to solve it faster. And then I simplified this terminology. So 2x squared plus 2x plus 1 equals to 25. I moved 25 over, and then I realized it will be 2x squared plus 2x minus 24 equals to 0. The benefit behind this situation right now is the fact that because all of these are multiples of 2, I just divided by 2 on both sides. What happens right here then will be 2x squared plus x minus 12 equals to 0. Once again, this is another box method. And I'll just use a different color just to diversify the colors here. Box method once again right here. And thus, when I factor this, it will be x plus 4, x minus 3 equals to 0. Thus, if I break this down and solve for each part, this is what's going to happen, where I could break down each part right here and solve it. And plus 3, x equals to 3. Thus, there's two possible x values that exist, -4 and 3. The tricky thing about this is that when you look at the answer choices that are provided right here in the question, you notice that they actually try to trick you a little bit right here. So like, they make you think maybe it's just 1 point, but it's not 1 point. This is actually representative. These answers right here are representative of two possible answers. And thus, I looked for x values of -4 and 3 and just knew right off that it would be D. And that concludes my explanation for number 5. So to continue on to the last question. So, okay, so it's right here. Okay. 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 Let's see. Backtrack my work. Okay. Oh, whoops. Okay. So for number 6, my final answer is E. And now I'm going to explain to you how I was able to get to this answer. For number 6 specifically, what occurs is that when you're working through this type of fraction, the important concept that you do need to know is based on the idea of like common denominators. Okay, oops, and I'm going to move this over to denominators. And so before I continue on doing so, I do want to copy the question and now go into depth. So when I have this question, and I'm going to just copy it real quick right here. So when I have this question right here, the thing for me is that yes, it does look very complicated, but the important thing you must do is just make sure to take things and try to combine things as much as possible on respective to the numerator, respective to the denominator, and then, work it out afterwards. So what I mean by that is that I'm going to focus on combining these terms together, and then afterwards work on combining these terms together right here in case there is more than just one term right here, and then do what I need to do. So in order to work with the blue, and I'm going to take the blue over to here and now explain to you what I mean by that. So and for this question right here, the jk minus j over k, the problem right now is that jk does not have a denominator of k. Thus, this means that in order to combine this, I need to create a k on the bottom to make this happen. So I'm going to take this jk over k, multiply that, minus j over k. And so what occurs is that when I do this, this is going to become jk squared over k minus j over k. And thus, if I want to combine this, this will just become jk squared minus j over k because of the common denominator rule. And so this is my new numerator right here. This will be my new numerator. And to do the same thing for brown, for example, there's not a need to do that because there's no two separate terms. It's together, and thus now I'm going to put these all together as one equation once again. Over k divided by j over k. Okay, so after I have done so, combining this equation together, the thing is that a lot of people get stuck on this. I notice a lot of my students get stuck on this part and not sure how to work around it. So I usually tell my students what to do afterwards is to write this out in a very, one line format. So it's going to look like this when you write it out in one line. Divided by J over K. And so by doing it in this format right here, and I'm going to highlight it out in a different color. So I'm going to just take this green color and do that. So this format right here is very beneficial. And so what I mean by that is that it lets you make sure that you could see that after I get to this situation, I could change this to a multiplication and I could flip this to be my reciprocal. And thus, I could do that right here, times K over J. And so the thing for me, at least, I noticed right off is that when I have, K, like sort of values like K on the top and bottom, automatically I could cross it out. I don't have to worry about that anymore, which is a big benefit. But the problem is that what I have jk squared minus j over j. And so the important thing you must understand now is that you must find what does this top part share, and all the parts must share the same variable in order to be canceled out from the bottom variable if they're the same. So this will be j k squared minus 1 over j. And if you notice right here, there's two j's. And now I could cancel that out. And that will help me get to my final answer, k squared minus 1. And thus, if we look in the question right here, k squared minus 1 will be e. And thus, number 6, my final answer will be e. And that concludes my explanation for today. Thank you so much for watching this video. Please do subscribe to our YouTube channel, like our Facebook page, or follow us on Twitter so that we could continue to make content like this. I hope you have a wonderful day.